For a regular Markov chain with transition matrix P, the powers of P to the nth power come closer and closer to a matrix whose rows are made up of the entries of equilibrium vector V. You can usually find the equilibrium vector by calculating a large power of P. Okay? Now, basically what this is a shortcut for the last problem. All right? So the last problem is not that bad. It's really not. It's not that bad, especially using the Gauss-Jordan website. But this is a shortcut. Now, the rub is you're going to want to use a shortcut every time, but you're not going to be able to use a shortcut every time. Okay? So it says you can usually find the equilibrium vector. Sometimes it's not going to be good enough because our tools aren't going to be good enough. If you can find a better tool, maybe it will be. Example 4 says, recall the Johnson and Northclean example again. So it's the same transition matrix that we've seen a number of times. Use large powers of P to find the long-range trend. So what I'm going to do is just go back to this matrix calculator and enter the transition matrix, 0.8, 0.2, 0.35, 0.65. Okay. All I'm going to do is I'm going to take that matrix A and I'm going to take it to something, to a really big power, okay, like 100 maybe, okay? Let's say I take A to the 100th power. You see some numbers that you've seen before, 0.6364 and 0.3636. Now, the problem with that is it's rounded off. So I'm going to kick up the sig figs let's just put it up to like 16 or something, just something big, so we can really, really see what's happening to the decimal. It looks like a repeating decimal, doesn't it? Okay, it looks like a repeating decimal. And so what we have here, this gets confusing, okay? If I did P to the 100th power, I'm going to get 0.63 repeating, 0.36 repeating, 0.63 repeating, 0.36 repeating. People don't know how to interpret this result. This is not a vector. Why not? A vector is a row. This is more than just a row. This is a square matrix, okay? So in order to interpret this, you have to understand what's going on. This is a transition matrix. All right, this looks like the transition matrix, but, okay, what you should notice is whether you go from Johnson to Johnson or Northclean to Johnson, no matter where you start, the probability that you end at Johnson is 0.6363. Okay? So the probability that you end up at Johnson is 0.63 repeating, and the probability that you end up at Northclean is 0.36 repeating. So don't write down a square matrix when the answer is supposed to be a vector, okay? The numbers on top of each other should match, okay? The numbers in each column should match. 0.63 repeating, 0.63 repeating, those numbers should match. And if they don't, you didn't pick a high enough power, okay? For example, if I did, like, let's say I only did A to the 7th power. Let's see. Did that go? See how if I do A to the 7th power, those numbers almost match. 0.637 and 0.633. Let's kick it down. See how those numbers don't quite match? That just means I didn't pick a big enough power. A to the 20th power. Okay, those numbers appear to match, maybe. Kick up the sig figs. Do those numbers really match? Those numbers don't quite match, so maybe I needed a bigger number. So that's why I want to go really big like 100, and make sure they match. Okay, now, the next problem we run into is you're usually going to have to give me a fraction. Okay, and so you've got this problem of how do we change a decimal into a fraction? Some of them are going to be easy. If you had 0.3, you'd know that's 3/10. If you had 0.3 repeating, you probably know that's 1/3, or 0.5 is 1/2. Some of them are easy. So on this one, it's not at all easy to tell what these answers are. We already know because we did it before, 7/11 and 4/11. But if you didn't know that, one thing that you can do is look for a decimal to fraction calculator, okay? So I have one. For some reason, the picture that I tried to put on here didn't work, but this website is a pretty good site for doing fractions, okay? So decimal to fraction. So notice if you just type in 0.63, okay? It says 63/100ths, which that makes sense because we haven't accounted for the repeating decimal. If you just go 636363, that's not going to be good enough because it doesn't, you haven't told it about the repeating decimal. So that's what this 2 is, right? Or this number right here. You're going to put a 2 right here to tell it that it's 636363636363, okay? Repeating. And if you'll do that, notice it puts the little bar over the 6/3, and it tells you that that answer is 7/11. Of course, you could do the same thing with your 3/6, and it's going to tell you 4/11. Okay, this site is pretty good. It won't do the job every time, but it's pretty good. And that tells me 7/11 and 4/11. Okay. So that's basically the same thing we just did. It's just a little bit of a shortcut. It's kind of nice. Okay. Again, the problem is, though, you're going to want to try to do it this way every time. It's not going to work every time. Example 5. Find the equilibrium vector for the Markov chain with this transition matrix. Okay. Find the equilibrium vector. That's what we just did. That was the equilibrium vector. That's where it stabilizes. That's the long-term trend. Okay, so probably what you're going to want to do is find a big power of that. So 0.2, the shortcut, 0.6, 0.2, 0.1, 0.1, 0.8, 0.3, 0.3, 0.4. Okay, so we've got this matrix. I'm going to take it to the 100th power and see what I get. Okay, I like that these three numbers all seem to match up. Match up, match up. But the problem is, I don't know what that is as a fraction, and you're probably going to have it as a fraction. Okay? And so then the next problem is, if you tried to type this into that website, it's going to be way too big. Plus, believe it or not, this is a repeating decimal. You just don't see it yet. So watch if I kick up the sig figs to 30. It takes a lot before you can actually see where it starts repeating. See how it starts at 217? You get through here, blah, 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 blah. All of this, blah, 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 blah. Oh, here's 217 again. 217, 391, 30. Okay, I can see right here at this 5 is where the repeating decimal is. So if you count all these, I believe that's 15 numbers before it starts repeating again. Problem is, when you go to this site, it's not going to handle a number that big. Okay? It's not going to handle 15 numbers. It's going to give you an error message that says that's too big. Okay? So what that tells me is I'm not going to be able to use the shortcut on that problem. And that's okay. That's okay. We'll just do it the other way. It's fine. We'll go the other way. Remember the other way, we had PV equals P. So we can do this. That vector, since there are 3 states, should have 3 variables. I'm going to call that vector X, Y, and Z. Those would be my 3 values or my 3 states. So if I do V, or, I said that backwards, didn't I? I didn't do that right, did I? Fix that. It's supposed to be VP equals V. Sorry about that. Fix that because that's a mistake. That would not do it. All right. So V times P equals V. Once you get the hang of it, you'll be able to multiply this in no time. You're taking row times a column, and then row times a column, and then row times a column, and you're going to have to equal, it's going to equal these numbers right here. Okay? So you're going row times column, and we're going to get 0.2x plus 0.1y plus 0.3z equals x. Row times second column, it's going to be 0.6x plus 0.1y plus 0.3z equals y. Row times third column is going to be 0.2x plus 0.8y plus 0.4z equals z. So there we have a system of equations. Okay? And you can subtract that x over, and you're going to get negative 0.8x plus 0.1y plus 0.3z equals 0. And you're going to subtract that y over, and you're going to get 0.6x minus 0.9y plus 0.3z equals 0. And you subtract that z over, and you're going to get 0.2x plus 0.8y minus 0.6z equals 0. Okay. Now we could have multiplied by 10, and in fact, that's what I'm going to do. So it doesn't matter if you did that a minute ago or did that now. I'm going to multiply by 10. I'm actually going to do two things. I'm going to multiply all these numbers by 10, and I'm also going to take out the variables. Okay, so let's go ahead and do the augmented matrix. We'd have negative 8, 1, 3, 0, 6, negative 9, 3, 0, 2, 8, negative 6, and 0. Okay, but here's the deal. It's not as easy to see as the last example we did of this, but that's not enough information. That will end up only being 2 equations, not 3, because one of them ends up being a combination of the others. So we actually need one more equation, and that's fine. It's the same thing as the other one. We know that those 3 numbers, x, y, and z, have to add up to 1. Those 3 numbers are probabilities, so those 3 numbers are going to add up to 1. So we've got another equation here. I'm going to go 1, 1, 1, 1. So I've actually got a 4 by 4. I'm going to go back to that Gauss-Jordan site. And we're going to do a 4 by 4. And enter in those numbers. Okay, once you've got them, Gauss-Jordan, Gauss-Jordan, Gauss-Jordan. The thing that's good about this side is it gives you the fractions, and that's what you're going to need. You can always go decimal from fraction, but sometimes it's hard to go the other way. 5/23, 7/23, 11/23. And that's your answer. That's your equilibrium vector. That's your long-term trend. Okay? If you wanted to think about that as decimal because it makes more sense to your brain, go back here and think about what this meant when we took a to the 100th power. I'm going to kick down the sig figs down to something more manageable. Basically, 22% end up in that first state, and 30% end up in that second state, and 47% in the third state, or, even do this. 5 23rds is about 22%, and 7 23rds is about 30%, and 11 23rds is about 48%.